In this video, we're going to use LTspice to create a series connected circuit and make some measurements. So the first thing, we'll go to the Analog Devices website and download the latest version of LTspice for Windows and install that. Alright, and then we're going to launch LTspice. Okay, so the first thing we're going to do is we're going to create a new schematic. So we do File, New Schematic, and then it comes up with this blank canvas. And you can either grab components, some of them are be up here, but if you need to actually specify the component, you can click on this icon, and this will let you actually select the component. But for this case, the resistor is already right here. So I'm just going to left click on resistor and use Control R to rotate it. And by default, it's going to assume I want to add another one. So I'll go ahead and do that. And I'll add one more. Okay. And so now it's going to want to add a fourth one. I'll just right click to get rid of that. Okay, and so these are our three resistors. We're going to connect these in series. We're also going to need a power supply and a ground. So the ground symbol is here. So I can grab the ground symbol and put it, say, there and here. All right, and this time I'm going to actually click on the component because I need a voltage source called voltage. So this is going to be my voltage source. And again, I'm going to right click to get rid of the second voltage source. If I want to move any of this stuff, I need to click on this hand button. Then what I can do is just highlight everything and move it down like so. Right click will escape that. And I want to connect these using wires. So I'm going to select wire here, okay, here, here, here. Okay. Now that I'm done adding the wire, I'm going to right click. Okay, so the next step is we need to select values for the resistors. So right clicking on a resistor, I want to change the resistance value. Now, if you right click on the designator, this is the reference designator. So this is just designating which resistor it is. So I'm going to leave that alone and just change the resistance value. So for the value, I'm going to use 1000 for this resistor. I'm going to use 470 for this resistor. And for this last one, I'm going to use 3300, but I can also write this in scientific notation. So I can say 3.3K for this last resistor. So I could have typed in 3300, but I'm going to just use the abbreviated version. And actually, you can either use 3.3K, but to use scientific notation, it would be 3.3 times 10 to the third. So I'm going to leave it like that. And the voltage, we'll just set it 5. Okay. So this is our setup. So we want to measure the voltage and current. And so we need to edit the simulation command. So we have the simulate edit simulation command, and we're going to do a transient analysis. And the stop time, we can really just kind of put whatever, but we don't want to make it too long. So I'll just say 0.05 of a second, which should be okay. All right, and so now what we want to do is we want to click this run button. And what this does, it brings up a waveform window. So if I want to measure the voltage across R1, R2, and R3, I'm going to move my mouse or cursor to the left side of R1, and then it becomes a red probe, and then I left click and drag. So I'm still holding down the left button. And when it becomes a black probe, I'm going to release. So when I release that, it's going to show me 1.0482 volts. Now, if you want to get even more exact, you can right click on the measurement here and add a cursor. So let's attach a cursor. And this will show you the exact value, 1.048218. So this is giving it to 6 digits of precision. Okay, but in a lot of cases, you can just go by what's specified on the actual scale and just read it from the scale. Now, to get rid of this measurement, I'm going to right click and hit delete. Okay, delete this trace. Now what about R2? R2 is the same way. I'm going to left click and drag, and that's going to give me about 492 millivolts. Okay, and then to get rid of it, right click, delete, and then to measure the voltage across R3, I do the same thing and get about 3.45 volts. Okay. Now, to measure the current, when you put your cursor over each resistor, the current actually shows up in the bottom left. And it may be kind of hard to read. It's in the bottom left corner where it says the current's 1.048218 milliamps. And so it gives that, it displays it automatically. Okay. You can also right click, or I'm sorry, left click, and it will show it just like it did for the voltage. Okay. And then to get rid of this, we would just right click, delete. And then if I left click on R2, left click on R3, it shows up on the display. Now the reason the current's reading negative is if you look here, it may be hard to see, but that when I hover my mouse over the resistor, it's showing a left-hand arrow. And so the way you would get rid of that is you could just rotate. So select each resistor and do Control R. Oops. and rotate the resistors. Now when I run it, it's pointing, the arrow's pointing to the right. So now I'll get a positive 1.048 milliamps. Okay, so when you see that the cursor is pointing to the right, that means the current's going in the direction that will give you a positive reading on the scale. And so that's pretty much it. Now the way you could actually measure the resistance is basically use Ohm's law. So you would take the voltage divided by the current. And so it's a little bit more involved, but I will demonstrate it quickly here. And so the first thing I want to do is, because I can't see what the different nodes are, if I go back to my schematic, right, and if I say view spice netlist, and so this shows me the connections, okay, and so for R1, you can see that R1 is connected between node 1 and node 2, and R2 is connected between node 2 and node 3. And so that means that and V1's connected to node 1 and ground. So what I would want to do is get the voltage between node 1 and node 2 and divide by the current. Okay, and so what I can do here is do add traces, and you can actually do expressions. Okay, and so what I want to do is I want to do parentheses VN1 minus VN2 close parentheses divided by IR1. So this will give me the voltage across, or the voltage at node 1 minus the voltage at node 2 divided by the current. So that gives me 1 kilo ohm, or 1,000 ohms for R1. All right, that's going to end it for this video. It's just kind of a quick little demonstration of how you can make measurements using LTspice.